Let's say that because we were math instructors and we love to kind of play around and manipulate things, mathematically speaking, to see what we can discover. Maybe we discover a new way to solve a problem that might be easier for us. And so this expression I'm going to show or share with you is one of those ways. So let's say, for example, that we're beginning with two known points. And from those two known points, can I come up with both the point slope form of the equation of the line and also to the slope intercept form of the line? Well, I think I can do that. So I have two known points here, and to separate them out, let's call one known point x1, the other one x2 or y2, y1, and then x2 and y2. Now remember, those subscripts, they only represent an ordering form for us, or a naming. It's a nomenclature. It lets us know that those are specific points that we know to exist on the line that we have. From our point slope form of the equation of the line, which we remember is y minus y1 over m times, or equals m times x minus x1. Well, one of the things in this equation that I don't know right now is I don't know what m is. I don't know what my slope is. But I remember I can find the slope if I have two known points. And I have two known points. So slope was my change in my y values over the change in my x values, which was a y2 minus y1, so 6 minus a 3, minus a negative 3, and a negative 2 minus a 4. Yep. So 6 take away a negative 3 gives me a 9. A 2 minus a 4 gives me a negative 6. And that reduces down to negative 3 halves. So I have a slope of negative 3 halves. So y minus y1 equals the slope between those 2 points times x minus x1. Now remember, in this equation, these two variables right here, x1 and y1, they have to represent something that we already know for sure. A solution to this equation, a known x and y point. Do we have any? Well, yeah. In fact, we have two. Here's a known point, and here's a known point. Even though I originally labeled this one as x1 and y1, and this one x2 and y2, I could use either one of those points because what I need to find is something that I know for sure already exists on the graph. So since this one's closer, I could use that one, and I could add this in there, so that'd be y minus a negative 3 equals negative 3 halves times x minus the x point, which is a 4. I can clean it up a little bit. I think it'd be y plus a 3 equals minus 3 halves times x minus 4. Either one of those equations is in our point slope form of the, either one of these equations is in our point slope form of the equation of a line. So the next task that we want to do is, can we go ahead and also find a slope-intercept form of the line? It's y equals mx plus b. And we can by just continuing to isolate the y in this one. So let's continue on. Let's subtract 3 from both sides. So y equals minus 3 halves x minus 4 minus a 3. Y equals minus 3 halves x. Negative 3 halves times a negative 4 gives me a positive 6. Minus a 3. Then y equals minus 3 halves x plus 3. And then by just doing some more little algebraic gymnastics, I was able to work itself down to its y equals mx plus b form.